we will go now to hear the presentation of uh, I think Bu Yasnita perhaps, Pak Edi Sutoyo and Pak Ahmad Musnansyah, who is I think who are going to present a paper on a hybrid seasonal autoregression integrated moving average, which is abbreviated as SARIMA, and decision tree for drought forecasting. Okay. So I think Bu Yasnita will present
Yeah.
Okay.
Okay.
Please Bu Yasnita, sorry. You have 10 minutes time, Bu. Yeah.
Okay, Pak. Good morning, everyone.
Morning,
I'm
Bu.
Yasnita, the representative of my group. Today I'm going to present our study. The title is A Hybrid of Seasonal Autoregressive Integrated Moving Average and Decision Tree for Drought Forecasting. So there will be 4 outlines for today, starting from introduction, method and result discussion, and the last is the conclusion. So let's get started from the first one. So this is the map of Indonesia. This map show you the drought distribution that happened in Indonesia in 2019. And the red color here is Central Java. This is one of regions in Indonesia that experiencing a drought with highest number of cases. And then the second picture here is trend of natural disasters that happened in Indonesia in the last 6 years. Um, with yellow bar, I think it is, yeah, with yellow bar indicate the number of events of drought cases. Drought is one of natural disasters that different from any other natural disasters. It is not occur suddenly like any other natural disaster, but it is occur slowly and the effect will also feel slowly too. Drought in Indonesia is actually one of is actually something ordinary. It is happen almost every year uh, in summer. But drought with quite high intensity occurs in 2018 and 2019. As you can see in this chart, before 2018 there were only dozens of cases of drought events, but the drought events increased high in 2018 to 834 number of cases and increased higher in 2019 to 1,529 drought cases, which affected 3 million people. Drought is also one of triggers for forest fires. That is why in this chart, as you can see, this along with the frequent of number of drought increase, the number of forest fire, which indicated as orange bar, is also increased high. That is why it is important to be known or predicted from the beginning. By prediction the drought, it might help much people, including government or communities, to take an action or precautions about drought possibility. So the solution of this study is by implementing data mining concepts, classification, and forecasting method. This classification method in the study is using decision tree algorithm, which this classification uh, aims to see the rules or pattern of drought from classifying the current data or past data. And for forecasting, it uses seasonal autoregressive moving average or SARIMA. Um, it aims to see the or predict the future value of drought factors. And then last, the result of forecasting will be classified using the pattern that we get from classification method. Based on meteorology state, drought related to rainfall, temperature, humidity, and any else. So we use the meteorological data, which consists of drought factors such as rainfall, temperature, and humidity. And last, the purpose of this study is to implement data mining concept, decision tree algorithm, to classify the current data, and SARIMA method for forecasting the drought factors. The next is the method of the study. So it is start from inputting the data, which is meteorological data, and then the data will be prepared in data pre-processing steps, and then the process will be separated into two process. There will be classification process and forecasting process. In classification process, data decision tree algorithm is implemented, and it will resulting in rules as an output. And in forecasting process, SARIMA method is implementing, and it will result in forecast as an output. Then the forecast of result of forecasting will be classified using the pattern that we get from the classification process. And then we evaluate the both of method using confusion matrix for classification and MSE for mean square error for forecasting. And then we get information about the result is we get the information about drought probability, and we also get the information about month of rainfall probability, temperature, and humidity probability, and then the end of the process. Then result and discussion. This part is also consists of some steps. First, we select the data. So we use meteorological data that consists of rainfall, temperature, humidity, or drought factors. We get the data from Stasiun Tegal, which is one of region in Central Java that also experienced drought in 2019. And the data is time series data that collected from January 2014 to December 2019. Total of rows of the data is 2,191, and we do the forecast for the next 3 years, from 2020 to 2022. Then the next step is data cleaning. This step aims to remove the anomalies in the data. And then the next step is data transformation. This step aims to transfer or change the daily data into monthly data, where the monthly data will be used for forecasting process. And then we calculate the KBDI. KBDI is an index for to check the drought events daily. This calculation aims to give a label or class for the data. And then the classification process. In classification process, we use decision tree card algorithm. This process also through some process. At first, we determine the feature and the target. The feature of the data is the drought factors, which is temperature, rainfall, humidity, and the target is the label or the class of the data. And then we split the data into train and test, 70% for training and 30% for testing. Then this is the result of algorithm of decision tree. It is resulting tree structure. It is an example of tree structure that we get from classification. This tree structure show the pattern of drought, and then this tree structure also this tree structure is converted into if-then rules, which these rules will be used to classify the forecasting result. And the classification result is evaluated using confusion matrix, and we get the accuracy of 91%. Next is forecasting using seasonal ARIMA. In this process, we select the best parameters based on the AIC criteria, and we get these models for each drought factors. And then these models are fitted and validated, and then evaluated using MSE score. And this is the result of validation. This blue line means the actual data, and the orange line means the predicted data, predicted value using the models that we selected for. And this is the result of mean square error. The closest result of MSE to 0, the better performance of the model. So we get this. MSE score closely near to zero enough. And then the next process is we use these models to build the forecasting. So this is the result of forecasting for the next 3 years of drought factors. This is
So Bu Yasnita, you have around 2 minutes, 1 minute time, ya Bu.
Oh iya Pak. Okay, then this forecasting result will be classified using pattern that we get from classification process. So this is the drought prediction or information that we get from predict the forecasting result of Tegal, Central Java for the next 3 years. And last is the conclusion. Based on the application of decision tree, which evaluated using confusion matrix, is able to gain an accuracy of 91%, and also we get the pattern or rule of drought. And based on the application of seasonal ARIMA, that selected based on AIC criteria, the model that selected are used to as models for forecasting. I think that's all. Thank you.
Okay, thank you very much for your presentation. So I have already got some questions here. Okay, so this is the question from Pak Anto Satyonugroho. So the first question is, what is the classification rule obtained by decision tree? Did you compare the rule with expert knowledge? So that is the first question, Ibu. And the second question is, the classes are not balanced. The number of data size of one class is greater than the other one. What is the effect of imbalance to the methods? In this case, decision tree and SARIMA. Okay,
sorry,
can you answer the question?
Can you repeat the first question, please?
Oh, the first, you can actually see the question in the chat book, but I will repeat. So the first question is, what is the classification rule obtained by the decision tree? Did you compare the rules with the expert knowledge?
Actually, I don't do comparing to the expert knowledge, but we took the general pattern that we get from classification result. Yeah.
Okay, but do you have the rule book actually?
Yes. Yeah.
Okay.
And the
second question is, the classes are not balanced, Bu. So the number of items in the classes are not balanced. So the number of data size of one class is greater than the other one. So what is the effect of imbalance to the methods, decision tree and SARIMA in this case?
The effect.
Yeah, do you understand the question, Bu?
Yeah.
Okay.
Maybe the effect of the imbalance of the class is affecting the test results. Yeah, I don't really know about the answer. Yes.
Oh, okay, yeah. Yeah, so the idea is, Bu, if the class is imbalanced, it could be that the accuracy is high, but actually you do not detect the small class, Bu. Let's say the class is 10 and 1, for example. Yeah, if you detect 9 or 10, all of them are considered as 10, as class, the big class, for example, the accuracy is still 90%, isn't it? But actually you do not detect this one.
Oh, yeah.
Do you understand the question? That is the concern, I think. Now, in your case, the class is like that. One is smaller than the other one. Okay, yeah.
The effect of imbalance is affecting the accuracy of the classes.
No, but do you quantify that, did you do some experiments about that to actually measure the effect? How big is the effect?
Honestly, I don't do that kind of experiments.
Oh, okay. Yeah. Okay. Okay. There is still no question, so perhaps I can ask okay, my question. Bu, you are using the SARIMA here actually to make the forecasting, yeah, Bu.
Yeah.
So why is it needed, Bu? Why don't we just use the result of decision tree directly?
Um, because as far as I know, decision tree cannot forecasting the value, but the Sarima could forecast or predict the movement of the past data or the past value to predict the future value. So I try to combine these both of methods, how to complete each other.
Hmm, yeah. So is it not that your decision tree will predict based on a given, let's say, data,
Mm-hmm.
yeah, that a drought will happen or not? Decision tree will do.
Pardon, but
I mean,
can you?
using decision tree.
Yeah.
I mean, is it not like that you put in a set of data, yeah, for example, what is the rainfall, the humidity, whatever your features, you put in that, and then the rule will give you a prediction whether there would be a drought or not. Is it not like that?
Is it like that? So we classify the data using the feature, and then it will result in the rules or pattern from the feature, resulting the rules or pattern from that feature to be used, where the rules will be used for forecasting.
Mhm. Yeah. What I mean is, it seems to me that the decision tree can do a forecasting, but okay. But I have another
Mm.
question here. So the question is, what is the benefit from this research to our community? Yeah. So what do you think would be the benefit of your research?
As I said before, that drought is one of triggers for forest fires. So maybe by predicting the drought, it could take precautions to communities or government, and to take an action about how, misal, example, how to do water, good water management or any else, and how to decrease the impact of the drought.
Okay. So as an early warning system, yeah, Bu, yeah, more or
Yeah.
less. Okay. Yeah. Okay. Bu, okay, I still have time, I think. Is there any question? No. So, have you actually compared your result, Bu, with other methods? For example, let's say random forest or a neural network, perhaps, or something like that?
Uh, I actually I haven't compared it yet, but um I do this we do this study based on some references of our method. So yeah, we actually don't do comparison to another.
You don't do comparisons. Okay.
Yeah.
So, may I ask, Bu, perhaps my last question is, why do you choose to do it with decision tree, Bu?
I think decision tree is one of easy to understand algorithm,
Mhm.
and it is also show the easy to understand pattern of classification. So uh, yeah, it's because it is easy to use, I think.
Oh, okay. Yeah. Uh, have there been also other previous research about drought forecasting before, Bu? Are they also
Sorry,
using
Pak.
uh, in your research, Bu? Have you done some, for example, have you checked what other researchers have done in drought forecasting? Are they also using decision tree, Bu?
Um, yeah, there are some reference that using decision tree, but they yeah, they're only using decision tree for predicting, not for forecasting.
Oh, okay, good. So thank you very much, Bu, for your presentation and for your answers. Okay,
Ya,
due to
Kak.
time, I think we have to move on, Bu. Yeah, thank you very much
Ya.
for your answers and your presentation.